Hello, I'm Mentor Kenneth Chow. You can call me Man Chow or Kenneth Chow. First of all, I apologize that yesterday I uploaded a video to YouTube, which was in which I pressed the wrong button because I was at the time in a public library, and it was a very crowded place with people around me. So I was distracted and I pressed the wrong button. So that video was extremely short, only 25 seconds. So it did not record the whole video. I apologize for that first. Yesterday, the topic was explanation of conservation of charge in the universe. The after the conservation of charge, I first have a quote as a paragraph from a ordinary popular science book. Of course, the conservation of charge is by Eugene Heck. It's called College Physics. It's on page 300. It said the algebraic sum of the charges in the universe is constant. When a particle with charge positive E is created, a particle with charge negative E is simultaneously created in the immediate vicinity. When a particle with positive E disappears, a particle with charge negative E also disappears in the immediate vicinity. Hence, the net charge of the universe remains constant. How do you explain that? I now wish to why. I have to explain why. How come the conservation principle and what is the charge really? This can be explained by the following facts. One, each hydrogen atom, which is the most abundant element in the universe, and the component particle of all other elements, from elements number 2, helium, to elements number 11H, Gaddison. Each such hydrogen atom has a Planck black hole. Why I call it Planck black hole? Because it's of Planck mass and Planck length radius. So that's the most appropriate name to call it, a Planck black hole. At the center of the hydrogen atom, which is, of course, a black hole is an attractor, a sink. Mathematically, it's called sink. It's an attractor or sink, as well as a source. It also has a white hole concomitant to each such black hole. And this, what's a white hole? White hole is a source, an emitter of matter. Such a white hole is predicted by a Martin Kruskal in 1961 by what we call the maximally extended Schwarzschild geometry. And what was the support for this white hole? This has been observationally observed as jets or halos emitted by the largest type of black holes, which is of course the galactic centers. Most of the numerous galactic centers by astronomers has been discovered that such black holes has concomitant jets or halos. Three. I have to number my paragraphs. Paragraph 3. Each Planck black hole attracts diploid matter waves, or diploid matter waves. Which has been it was posited by the physicist Louis de Broglie in 1923, and thereafter have been verified experimentally by Davidson, Thomson, and others. It's verified experimentally, proved. I mentioned above that it's the black holes attracting these diploid matter waves. This attraction has hitherto been interpreted by the scientific community, of course, as negative charge, negative E, the electron, the charge of the electron, and being attracted by the positive charge, the positive E, the proton. But the proton is an outer surface embedding the Planck black hole at the center. And the proton itself is also a diploid matter wave. The concomitant white hole of each such Planck black hole has hitherto been interpreted as a negative charge, negative E. Why? Because the white hole, the concomitant white hole, emits matter also in the form of diploid matter waves, and such diploid matter wave emitted is attracted by nearby Planck black hole. So that was therefore it was interpreted as a negative E because it was attracted by a nearby Planck black hole positive E. So it is interpreted as negative E. Both the Planck black hole and the white hole concomitant to it are themselves also diploid matter waves. The wave nature of them, as well as the wave nature of the proton and of the electron, can be proved by the relation h bar equal to mass times radius or wavelength, radius of wavelength, times c. That's the h bar is just h, the Planck's constant, divided by 2 pi. C is the light velocity in air or vacuum, because the vacuum is not much different between the velocity in light in air or vacuum. In air, this relative permittivity is 1.00054, whereas in vacuum it is 1. And what is this relation? This relation means angular momentum h bar is equal to mass of the wave times its wavelength, which coincidentally also is its radius, the wavelength, multiplied by this velocity of rotation. Paragraph 6. A neutron is also a diploid matter wave. It is a proton with the diploid matter wave exterior to it, which we usually call the electron, compressed by gravitational pressure in a core of a star or inside a star-producing nebula into the proton itself. It also satisfies, the neutron is also satisfies the relation h bar is equal to mass of the wave times wavelength, which is incidentally also is radius multiplied by c. A free rate, how can we account for that? We can account for that intuitively. By intuition, a free neutron releases an electron and itself turns back into a proton in about 886 seconds, and plus the energy it had acquired in the compression. It releases the electron as well as some energy. The energy it acquired in the compression, which has this energy was so far been interpreted as an anti-electron neutrino. It was first interpreted as an anti-electron neutrino by the physicist Eugen Pauli in 1930. In the state of a neutron, while it's still a neutron, it does not attract or emit the Broglie matter waves, and therefore it has been interpreted as a neutral in charge. As regarding, you have more question about the mechanism of creation of the Planck black hole. You have such theories, and you want to evidence of the existence thereof, that you can refer to my quantum gravity YouTube series, in particular video 2, 3, 4, 16, 18, and 19. You can refer to that for elaboration. Secondly, I will now come to an explanation of the forces of nature and the unification thereof based on the new hydrogen atom model. Based on the concept which I just mentioned, the concept is of the Planck black holes and in the universe, which has more than 10 to the power 80 in the universe. Because why? Because each hydrogen atom has a Planck black hole in the center. How many hydrogen atoms in this universe? It was estimated not less than, but exact number no one knows. 10 to the power 80 more than. The Planck black hole, which just mentioned, it attracts de Broglie matter waves. Such a concept can be epitomized and abbreviated to a single terminology. That's to say the new hydrogen atom model. The new hydrogen atom model. Now using this concept, the new hydrogen atom model, that's to say the Planck black holes attracting and repelling the de Broglie matter waves, I can explain the unification of the four forces of nature. I have mentioned thereafter we call it 1, 2, 3, 4. 1 is the strong nuclear force, 2 is the electromagnetic force, 3 is the gravitational force, 4 is the weak nuclear force. Firstly, the strong nuclear force is the force of attraction experienced at a distance of less than or equal to that from the surface of the protons, which is 0.21 times 10 to the power minus 15 meter to the event horizon of the Planck black hole. The Planck radius, which is also incidentally also the Planck radius, 1.616 times 10 to the power minus 35 meter. 2 is the electromagnetic force. It's the force of attraction by the Planck black hole, or the force of repulsion by the Planck white hole, which is concomitant to the Planck black hole, depending on the position and orientation at a distance from the electron or object comprising the electrons to the Planck black hole or white hole at 1.616 times 10 to the power minus 35 meter, which is the Planck length, which what we usually call. This distance is can range from infinity to 3.86 times 10 to the power minus 13 meter, which is we call the Compton wavelength of the electron. 3 is the gravitational force. This is the force of attraction by the Planck black hole, or the force of repulsion by the Planck white hole, depending on the position and orientation, again, at a distance from the object in question. An object, you must remember, it's a huge assemblage of molecules or atoms to the Planck black hole or white hole of another object. We usually consider gravitational force, we consider gravitational force between two objects. We do not consider between one electron and another electron, or one proton with another proton. We usually consider between objects, which are a huge assemblage of molecules or atoms. And this range of distance can range from infinity to circa, that's about 10 to the power minus 3 meter. What is 10 to the power minus 3 millimeter? Just a millimeter. You have to explain a little bit. When gravitational force is considered, the usual circumstance is between one object and another. Thus, the minimum distance between the two objects is circa 1 millimeter. Of course, one object cannot crush into the other object. We usually consider the force between them, the nearest distance between them is 1 millimeter. Just take that, 1 millimeter, 10 to the power minus 3 meter. 4. The weak nuclear force. The weak nuclear force is a force of attraction by the Planck black hole or force of repulsion by the Planck white hole at a distance of less than or equal to that from the surface of the proton. That is to say 0.21 times 10 to the power minus 15 meter to the event horizon of the Planck black hole. That is to say 1.616 times 10 to the power minus 35 meter. I have already given an example of the big force. Bigger force above. That example is I say yes, I have given example that when in a free state, when there's a free state neutron is in a free state, that means it's not bound in a object or in a molecule and so on, then it turns back into a proton in 886 seconds, and it releases an electron. It also releases some energy, which has hitherto been interpreted as an anti-electron neutrino. Such a weak nuclear force interaction is um, is such a nuclear force action, and this means it is repelled by the uh, the force of repulsion from a Planck white hole. When it is a free state, and if we consider it's a free state, then there is no force of attraction by the black hole which can cancel it. It is repulsion force. Another example of a weak nuclear force is the radioactive decay or fission of heavy elements. In such cases, the force of repulsion is due to many alpha particles being repelled by the Planck white holes of many other atoms in the same heavy element. But the force of why is the force of repulsion so weak? It is actually the same force as the strong nuclear force, but it is much weaker because the repulsive force is partially cancelled out by the attractive force due to the other Planck black holes in many of the other hydrogen atoms in the heavy element. It was repelled out, but is also attracted by many other hydrogen atoms in the same element. So in the same heavy element, it's usually a heavy element, uranium and so on, radium, etc. And therefore, this such repulsion or attraction, it will be according to the positions and orientations of the alpha particles being repelled. But nevertheless, it's the same force. You will have noticed that when I talk about the two, that's about the electromagnetic force, and three, the gravitational force, my interpretation of 2 and 3 are almost identical, except in 2, that's the EM force, the electromagnetic force, a single electron and objects comprising electrons are considered. But in 3, where we will only consider objects between objects, one object and another object. You are correct that 2 and 3, the interpretation are almost identical. Because under the new hydrogen atom model, all 1, 2, 3, 4, the forces 1, 2, 3, 4, the strong nuclear force, the electromagnetic force, the gravitational force, and the weak nuclear force, they are just the same force, one and the same force. But the one and the same force we consider at different distances. And also, the other difference in consideration is whether single proton or single electron or objects between two objects comprise a huge assemblage of protons and electrons are being considered. That's the difference is the distances considered between. I mentioned distances from between them. That's in the first case, the strong nuclear force is from 0.21 times 10 to the power 15 to 1.616 times 10 to the minus 35 meter, the Planck radius. And EM force is from the infinity to, for example, I've given this example, to 3.86 times 10 to the power minus 13 meter. That only this difference in the distances and difference in whether single electron, single proton, or objects, a huge assemblage of electrons and protons are being considered. But you can see that 2 and 3 are almost identical, my interpretation of these two. They can actually oppose or camouflage as each other. Camouflage. Speaking correctly, it should be said they are misunderstood or misinterpreted to be two different distinct forces, whereas they are in fact the same force. Whereas it is difficult to imagine that gravity can be understood to be the same as a strong nuclear force because of both of the magnitude and the sort of the range distances considered are vastly different. Gravity is considered for a huge assemblage of electrons and protons, whereas when between objects, and whereas the strong nuclear force is we consider between one proton and another proton and so on, or one proton and electrons. But I've mentioned in my quantum gravity YouTube series, video 6, that electromagnetic force, when measured at the distance 0.21 times 10 to the power minus 15 meter, that is to say, the proton wavelength, proton ring radius. When the EM force is measured at the proton radius, it has the same magnitude as the strong nuclear force. You can refer back to my video 6. It's not surprising because they are in fact the same force. And only the distance considered are different. And the distance is not much different because one is 3.86 times 10 to the power minus 13 meter, the Compton wavelength of electron, and 0.21 times 10 to the power minus 15 meter proton radius wavelength. It's only about 100 times, a bit more than 100 times. In fact, it's nearly the fine structural constant. That's 1/137.036. And we have many queries about the proof of the identity, that is to say the same, of the EM force and the gravitational force, and how the EM force can pose as gravity. That's how we can misunderstand them to be the different distinct forces, whereas actually the same force. And if you have such queries, then you can refer back to my quantum gravity YouTube series, videos 5, 13, 14, and 15. My today's video is finished here. Thank you for watching.